Alrighty, I think we'll kick it off. Good afternoon, everyone. Thank you for coming. Before we get to the good stuff, I've got to cover a very important topic. Who here is wearing shorts? Anyone? Anyone else? Just the one? You, sir? Thank you. Skirt counts. If you're Scottish, it double counts. This was my big decision today. Do I wear pants or shorts? My entire life, I've pretty much worn shorts. Every job I've had, I've worn shorts. I went to the office one day and I had pants on, and the first question I got was, "Are you having a job interview?" I was like, "No, I'm meeting a customer who doesn't get the whole tech bro shorts thing." So I reached out to my OG Amazon group of all my co-workers from, 13 years ago now, and put a poll to them, and they said, wear shorts. Be your honest self. So that's what I've done. It also means, as Chris identified, I can show off my company socks. I wish I had some to hand out today, but someone didn't bring any. He's sitting right there. So thank you, Aditya. On to the main topic. So, why grass-fed makes the best burgers? Now, this is one of these titles that just comes up once in a lifetime, because the topic you're talking about, the technology, the names, and everything else that you had no control over all sort of comes together to make something obvious, or at least to me. And an old Toastmasters trick, if you're going to have a talk, have something interesting to sort of catch people's attention. And just like other people have said, there's no AI today. I don't really look at it. I should. I'm a bit further in the denial process, or the 7 stages of grief about AI. I'll get there eventually. On to the next slide then. So, quickly, what does software at scale do? They're the guys I'm working with at the moment. About 100 people, and basically we come and help companies who have got themselves in a bit of a pickle and they've got no time. That's where the scale bit comes. So distressed project rescue, for lack of a better phrase, is one way of summing it up, across all disciplines and fields and whatnot. Come in, help the customer out, get them to the where they need to be without, how do I say this, wasting their time with constant statement of work and working to contracts as opposed to outcomes. So that's what we do. A bit about me then. So after university, I spent about 10 years in China. I did a managed hosting startup in there with some friends. Fell into that completely random, like my entire career has been. Did a bit of consulting after that. Then I did Amazon for 5 years. Then Adobe with managed services. There's a bit of a theme coming here. Same thing at Versant. And then back to doing consulting again. And I finally get to do what I do best, which is be a generalist. I'm not really an expert in anything. I just know a fair bit about a whole bunch of stuff, which comes in handy at times. What I want to talk about today is, it's twofold. There's not going to be a lot of tech. There'll be some. I've got the slides hidden. I might unhide them if you want to go into little diagrams of cloudy stuff. But the main story I want to get across today is a journey I went through, a journey of discovery, to sound like a bad movie subtitle, which I feel fortunate to have gone through. It's a small thing. I take no credit for discovering the path I came along. It's just one of those random things. And I wanted to try and take you guys through that journey. And maybe you'll come to the same conclusions that I did, and some of the realizations which I had as well. The burger part, this is the first part of the first clue to the title. Already had it up, there we go. So, the other part of this is a little Aussie success story. Who's heard of McDonald's? Okay. Anyone been in a McDonald's today? Yeah. Anyone else? Just one? What about Starbucks? Who's been to Starbucks today? Anyone? Burger King? KFC? Chick-fil-A? GYG? Dunkin' Donuts? Anyone? Well, all those places, apart from being food service companies, some with drive-through, some without, you may have noticed, especially for old people like me, they don't have those little, menus behind the screen where someone puts the little letters in one by one. They're all digital now. And those digital screens, those digital menus, both in the restaurants behind the counters and also on the drive-through, are all run, powered, and developed by hardware and software stack, run by a little Aussie company in Sydney, out near the airport. Who would have thunk it? So a little round of applause for Australia, punching above our weight again, just like in the Olympics. Now these guys Coates started as a business as sign makers. One of the first customers or providers to McDonald's back in the 1920s or 30s, whenever it was, doing physical signs, and now they've moved on to digital signs. So if you can imagine, does someone want to guess how many screens there are around the world that would have a menu on it in these restaurants combined?
50.
Screens. That's a pretty high guess. More than 12? Anyone else? 2. So there's about, and I'm going to guess here because I know they account for the hardware that drives it, and we're going to say there's 2 screens per hardware device. There's currently about 125,000 little devices, so about 250,000 screens, which is very close to 50 million, you know. It's just, you know. So these guys do their stuff, and whenever I turn my head, this doesn't pick me up, so I've got to face this way and talk. As you can imagine, there's lots of stuff in this industry, in this area of static signs, interactive stuff. It's a whole ecosystem, the all the different ways you house it and mount it and present it. By the way, it's it's projected to be 200,000 devices by the end of 2026. So it's growing. So this is what one of the labs looks like. There's rooms and rooms of this out at the office and the offices around the world where you can see the little arrow pointing, the little device, that's media player, little embedded industrial PC. They come in all shapes and sizes. You can also get them now in little SODIMM, like the memory socket formats, which you can plug into smart TVs and whatnot. There's some more pictures of what they look like. And here's my lab. This is what's responsible for what's getting rolled out, the 200,000 devices around the world. And as you can see, it's very professional. It's very well maintained. And I've put a little arrow there to something. Can anyone guess what the little arrow is pointing to? Did anyone have a job before the cloud in IT? Okay, it's a cable tie. Okay? Now, cable management is next to godliness. Like anything in life and tech, keep things clean, keep things organised, don't make a mess. And it starts with the simple things like having your cables tied up nicely. If you can't keep your cables neat, how can you keep your code neat? How can you keep your business operations neat? It all flows from the cable tie. So I've got this problem. Well, Coates has this problem. Hundreds of thousands of devices. How do you manage these things? And I say that because they have a management system now, as all companies have a technology, but eventually things grow and a point comes where you need a better way of doing it. And this sort of point has come to Coates. So my little bit of AI-generated art here, the prompt was very simple. There were no prompt rules and no groundwork, and there was no planning into the prompts. It was just draw me a picture that depicts a shepherd trying to herd computers. And that's what I got, because that's how I felt the problem is. How do we, get all these computers together? How do we manage them? So in loose terms, how do we manage, say, permissions that these devices have or how to log on? So this is where the Jerry Springer bit comes in. You've got a lot of these little devices. They're running Ubuntu, so they're essentially little servers. We need to centrally manage authentication and security and access. How can we do that? Let's get out some typical solutions to that sort of problem that jump to your head straight away. Again, if you're not Gen X, you won't get that. But if you are... Sorry? Chemical cloud. Canonical cloud, yes. Bit pricey, but yes. What else? Anyone else? Fleet manager? Oh, come on. I meant to show you the next slide, and it's like I've read your mind. No one's guessing the same things I thought of. No? Okay. This is what I came up with. And this is part of my journey I'm trying to get across today, is that when you do something a lot, you do it often, you tend to get sort of in an automated mindset. You know the solution to certain problems. And that's not a bad place to come from. Things are tried and they're true, they make sense. But behooves you at times, and there's a lesson I learned, to try and look outside the box. So initially we had these ones, AD, LDAP, anyone else who's very old, NIS. And this is what you go to. But my thought was, is that going to scale for 200,000 devices? What's going to be the cost of that infrastructure to manage? What about the license fees? Is it going to be something you have to keep rolling out? Would you ever have a known state for everything? Because you've got this sort of Amazon phrase, eventual consistency of where data is going to be. So this came up. And I parked it at that. I went and researched some of these solutions and costed them out. This is the cost we need, as in cloudless services, and this is the cost we need in people. We had another issue. These devices do a lot of cloudy stuff. A lot of cloudy stuff often works with tokens and permissions and roles. How do we manage that? They've got a system now for dealing JWT tokens, but it's not, it's not going to make it. It's going to get harder and harder and cost more the larger things scale. So then I started to think about, well, how do we manage that security and cloud access side of an application? Back to this guy. How do you solve permissions and roles and access and all that sort of stuff in the cloud? What are some of the tools that we use? Security groups, that's networking. What about something a bit more general in the application layer? I need one person to guess one thing that's on the next slide. Thank you. So, again, you do this all the time. We solve this. Instant roles. IAM roles. STS. Yeah, great answer. Works very well. But they're for the cloud usually. And I thought about these things and I thought, wow, that's easy. That's great. That's why, for those of you who had a career before the cloud, that's like one of the reasons why you want to go to the cloud, because that sort of stuff was made easy. And this is where my little revelation happened. And it's not because I'm smart or great. Maybe it's like one of those things that comes from interstellar space, those radiation that can flip a bit on a silicon chip. And it flips some brain cell. And I said to myself, wouldn't it be great if we could manage these devices and the applications that run on them like we do in EC2 instance and their apps? And from that one thought and that one pause started me down a rabbit hole, a good rabbit hole of research and discovery and learning. And that's going to take you through right now. I'm putting this one up. In Toastmasters, they say, put up a blank screen, because people then focus on you, not the screen. I put this one up because I'm not going to show any more slides for the time Anna's going to talk. So there's all these solutions out there. How do you run this on site? How do we manage, let's pick two. Authentication, your SSH login. How do we manage tokens for applications so they can consume stuff from the cloud? How do we do that in a secure, easy, and scalable manner? Looked at a few different solutions out there. There's Amazon Systems Manager, that works well, but you've got to use what's called I think it's called a dynamic pool, which is what they name for non-cloud pools. It gets very expensive. Usually it's not a concern, times it by 200,000, things get very expensive. I looked at a few different things using maybe AWS CLI. Could we script some things? Could have things going back and forward? A lot of these solutions would work, but again, not at 200,000, because you've got to build all the support systems and the inventory management systems around it. Like if you've got certificates, how are you going to manage the issuing of certificates, the revocation of certificates, all this sort of stuff. And then during my research, I came across something called IAM Anywhere. Not too new, but reasonably new. Who here has heard of IAM Anywhere? Oh, okay. That's a better response to my other questions. Yeah, IAM Anywhere. It is what it sounds like. You can have IAM roles anywhere. Amazon's not really not known for cool names. If you want to hit me up after, I'll tell you some of the absurd ones they use internally for stuff. IAM Anywhere. And I tested it. Brilliant. Like, everyone's getting super excited. Wow, I can do this, I can call that, I can call Lambda, it's all done. Yeah, just like EC2. But there was a problem. You had to manage the issuing of certificates, or what they call device certificates. And that chain of command. And that's complicated. And as anyone in IT knows, the two things that no one understands quite well is DNS and PKI. So I didn't want to sort of get into that sort of rabbit hole too much with 200,000 devices. So, but it was a good solution, and it's very, very cheap. Who wants to guess how much IM Anywhere operating with a couple 100,000 certificates would cost for 200,000 devices? $50? That's better than 50 million, but not quite. Anyone else? Nah. Bit higher.
437.
About $4.5 grand. So, pretty good. By comparison's sake, AWS SSM, who wants to guess what that would cost for 200,000 devices in their dynamic group? It was about $5 or $6 million a month. So, no prizes for working out why that idea was quickly put to the side. So we had a solution. It worked well, IM Anywhere. Awesome. But we have to build all this infrastructure to manage certificates. In order to issue a certificate, you have to have credentials elevated to allow you to do the certificate rollout, and you have to remove those credentials. That whole provisioning thing was a wide open door for bad actors to exploit potentially, and also a lot of overhead. And you've got to build a system to manage it all, because you're not going to have people go into Amazon Certificate Manager and do stuff there. You're going to have to build an interface around it. And I don't know where it came from. And this is the other part of the name, if you haven't guessed already. Who can guess what the other part of the name is that made up? We've got the burgers from McDonald's. Who can guess the next thing? And no one at the front can answer. Who can guess the next part of my discovery which led to the title of today's speech? Ding dong. If I had socks, you'd get a pair. Again, this guy's fault right here. Put your hand up, Aditya. Yep, him. So, Greengrass. So, I started looking into Greengrass, and look, and Greengrass does a whole lot of cool stuff. But it also has that whole certificate key issuing, management chain, and deployment mechanism, fleet deployment, as part of it. I like to call it essentially for free. So you get all that infrastructure, all the management of keys and everything, just because that's how it works. So it's almost like, in my opinion, a better version of IAM Anywhere. Much simpler to use. Then I had another title at the beginning, but I changed it. This is where a customer problem turned into customer opportunity, because as we dug into this more, ideas on how to solve the problems we thought were going to happen, and we know are happening, with Greengrass, we started to realize, wow, there's all these other problems which without looking into them too deeply, I'm pretty sure some of these can also be solved with an application or a mechanism that is built atop Greengrass. And as more and more things went on in the company in different areas, you started to see more and more use cases where a Greengrass foundation would enable better solutions for all this other sort of stuff. A bit like back in the day, we could see the reasons for moving to the cloud. You've thought of a few good things, but you're sure there are more you haven't discovered. Same with Greengrass. And it was really, really exciting. So what did we get to? Who wants to have a little bit of a tech example of how Greengrass can solve this? So here's the tech slide I have. So move this over. We have two use cases I mentioned before. Switchboard's the application that runs. It needs to consume JWTs. Currently, there's a mechanism where it can consume JWTs to get them from a Lambda function, but there's a whole manual authentication process built into that. It's cumbersome, it's hard to manage, it doesn't scale. SSH login. By default, you use what they call the shadow file system in Linux. And of course, there's NIS or LDAP AD. If you want to, you can use Samba, all that sort of stuff. But all those required back-end management. In our business case, even though these are full Linux servers, not multi-user systems, there's no need to go into them unless something really weird has happened. So logins are very rare, and it's only by a small group of people, like less than 10 in the world. So do we need a full-on username, password, directory structure like you get with AD and all the effort? No. We just need a password which we can rotate easily. We can control its complexity based on companies' laws and rules around policy, and we can revocate it. And once it's issued, it doesn't matter if the engineer who took it goes postal and posts on the dark web or disappears, it doesn't matter because that password's going to be... So, and again, anyone who's old enough who had a career pre-cloud, who's heard of PAM here? Yay. Fellow grey-haired guys, thank you. So, yeah, PAM, Pluggable Authentication Module. It sits in between SSH and the cloud, and basically allows you to program an interface. So by default, out of the box, you can have Linux look up all these different authentication services, or you can build your own PAM module. So what happened is Greengrass Core, which is running on each device, gets its own sort of credentials, and you can apply a role to that, and you can apply entitlements. We then had these little things called brokers. Greengrass runs the little applications. So I said, let's just run a little broker, a little HTTP agent, which receives a request, username, password, sends it back to a function in the cloud, a Lambda. Its permission to use the Lambda is based on the credentials granted to it by the Greengrass Trust. That function goes back, looks at the database, pulls back the username and password, compares it, gives yay, nay. And that gets fed back to the broker, back to the PAM, back to SSH, you get logged in. That password's stored in Key Manager, or Secrets Manager, sorry, and that enforces the policy, and it also updates every like 5 minutes. So you know that that password's only good for 5 minutes. And there's a whole system where people have to log in. I need to break glass, access the system. Who are you? You've logged into the organisation with your SSO. Give me a password, please. Or logged, complete trail back. And because it's instant, you're not waiting for a password to push out. At the time of logging in, the system will check back to the cloud. So there's no eventual consistency. So it's really secure. Same sort of a process basically happening for JWTs. Okay? So all this is done based on the fact that we've got Greengrass running, we've got these little brokers running, and we can then grant permissions to those brokers based on IAM roles and policies. So it's just like, then we can build our applications on the device to interact with the Greengrass layer. You can also run applications in Greengrass, you can run Docker in Greengrass, but, you know, life cycle of adoption. So that's where we came to, and the exciting thing is that the cost of doing this for 200,000 devices was roughly only about 30% more expensive than solving these two problems individually. And if you didn't use Greengrass for anything else, it's only about 20% more, but it's infinite use cases for Greengrass thereafter, for solving all the other things. So we came up with an audit recently about crypto key rotations, other applications that need tokens. Not AWS tokens, just other tokens in general. All this can be built onto Greengrass. Greengrass can run its own secret store. It can run its own local secrets manager. It can run an encrypted file space. So you can like mount a locally encrypted thing with all your source code in it without having to have a TPM chip or an encrypted hard disk, which, yeah, it's $20 a device for an encrypted disk, but times that by 200,000. You know, there's always someone in the room, they usually have an F in their title, and they have issues with spending money. So that was the discovery I came to. And that was a journey I went through, was that using solutions that you're aware of to solve problems is fine. But try and step back, try and pose yourself questions, and then go and look at the answers. And in my case, that was, I wish I could do this like I do it in the cloud. So I'm pretty sure any problem you encounter in tech, you can think of other problems in tech that are solved in really great ways. Think about those other problems and how they're solved, and try and learn from that. Learn from the methodology or thought process and see if anything like that can apply to your current problem right now. It may not. You may be stuck doing the same old thing, or it may make no difference because you've only got 20 servers. But occasionally you may come up with an idea which not only solves a problem, it also leaves a fundamental new capability in your customer's organisation, which they can build on and do more things. And those people with the F in their title, they like that because that increases the ROI. Because every new project that comes on, your groundwork's already there. Your trust chain's there. And you can do cool things like someone fiddles with a network cable, someone tries to plug in a USB device, you can detect that, bang, yank their certificate straight away. So that device is no longer trusted. Because as you can imagine, a device or a system which controls the screens, hundreds of thousands of screens all around the world, is a tasty target for people who either don't like those customers, just want to get out a message for whatever reason, or just want to chuck a tile of dirt and cause chaos and mayhem. So security is a big thing. I'm going to skip the next slide. So, summarise again. Cross-pollinate your ideas. Seek out others. I'm a pretty average engineer, and I use that to my advantage because I know when I'm hit my limit. And I have no shame or shyness in going and reaching out to other people and asking them for advice or their ideas, because no one's got a monopoly on great ideas. So seek others out. Think big or daydream. Doesn't hurt. Some of the best ideas can come from just sitting back and saying to yourself, maybe this could be done, without saying to yourself no straight away. And watch out for the autopilot mindset. That's what I was trying to get across before those examples on AD, LDAP, and then whatnot. The most common regular solutions aren't always the best solutions potentially. So try and think beyond that. And lastly, thank you. Again, we were given these codes to get feedback. So I'm already in trouble, even though it's not my fault, because Aditya didn't bring the socks. And a lot of hotel bills and airfares were paid to get me here. So to redeem myself and maybe spare him in the process, good reviews there will be very much appreciated. And shout out again to the dude in shorts. Thank you, guys.